Okay, so we're going to look at the paper two. This is from 2016 to 2020. We'll try as much as possible to finish up everything, just like we did the last time. Then, if possible, we will do the application of the logarithms as well. Then, if there is time, we'll do the sketch of the logarithm functions. So the first question shouldn't be that complicated. We're told to find the value of negative log p squared base p. So we know the
So it's
property
-2.
is negative 2. Okay, so that's the same as that's negative 2 log, negative 2 log p base p, and this equal to that answer this question. So yeah, there's not much of a challenge. Then this one, what do you think we're going to do with this?
-n.
Okay, so this log 10 raised to the power negative n base 10. So there's negative n log 10 10. It's equal to negative n. Mention. Then this one.
Um, say I'm coming.
Okay, so one thing I have realized is that bases are not the same. So this is
Yeah,
10 and this is 5.
this base 5.
So what I can do will be swap of bases because this is 10 and this is 5. I can easily do the swap of bases. So let's simplify the top one. Since it's subtraction, we can divide the logarithms.
This
Then,
log 5 thing.
okay, so there's 20 over 4 divided by log 5. This was given as log y all squared.
Okay.
So see log 5 because 20 divided by 4 is 5 divided by, now swap of bases will give you 1 over log 5 base 10. Remember the
Yeah.
swap of bases?
Yeah.
Okay, so this equal to log y
Y
all.
all squared.
Okay, and because this is division, we keep the first one, we switch the sign, and we flip the fraction. Okay, so there's the same as writing log 5 all squared equal to y all squared. Is this okay?
Yeah.
Okay.
Say, but isn't log 5 times log 5 1?
No, no, no. Log 5 times log 5. Now, why do you think it's 1?
Isn't it like multiplication rule? You add the
No, I told you that
argument.
this addition to multiplication. It's
Uh,
subtraction to division. It's indices that changes multiplication to and so we have to remember this one. This is for log.
okay.
It changes multiplication from subtraction to division. Each agent that is indices. Is that okay?
Yes, please.
So log 5 times log 5 is the same as writing log 5 all squared.
Yeah.
By comparison, or I can say that taking square root of both sides, you get log 5 equal to log y.
Yeah.
So since one log at the left hand side and one log at the right hand side, we can say that y is equal to 5. And that one side of the question.
Yeah.
Okay?
Yes, please.
It's following that challenge. Okay. This one, the bases are the same. So there are two ways to solve this one too. We can either input all the logs to one side, or we keep one log at the left hand side and we keep the log at the right hand side and simplify the left hand side. Then it creates them. So I'll do mixed methods. This is base R and the argument we are adding them, so we have to multiply the
Yeah.
argument. So this is log 2x times 3 will be 6x squared
Okay. Okay.
R is equal to log 600 base R. So since there is log base R over here and the log base R over here,
Because
because
bounce.
this
Yeah.
is very easy. The condition
Yeah.
to this is there should be only one log at the left hand side and only one log at the right hand side. So I couldn't
Yeah.
have cancelled the log this way. This would have been wrong because I would have gotten 2x plus 3x equal to 600. This is wrong. Okay.
Yeah.
So make sure that before you cancel out, there is only one log at the left hand side. So that's would make it for you to cancel. So there's 6x squared equals to 6 multiplied by 7 because x squared equals to 100 and x is equals to positive or negative 10. But it can't be negative 10 because of the equation. So x equals to 10. Okay?
Yeah.
Okay, so another one would be for you to fix yourself the cancellation, I would advise you take everything to the side, which is going to be a long process, but I think it's worth it. So there's going to be x plus log 3x, then minus log 600 is r equals to 0. So this simplifies to log 6x squared over 600 equals to 0. Is that okay?
Yeah.
Okay, so from here, we can that we can change the logarithm to exponential. So this becomes 6x squared over 600 equal to 10 raised to the power 0. Agree?
Yeah. Which is one. Okay.
So 6x squared equal to, or let's say
Six.
x squared over 100 equals to 1. We first multiply x squared.
100.
So this one, we didn't
There's
cancel.
longer.
Yeah, it's longer, but I feel that it's safer so that you don't go and one day cancel out and this one, and this will get you the answer to the law. Okay, this is longer. The second method is longer. The first method is fine. That is, if only you remember that you can only cancel out if there is only one log at the left hand side and there is only one log at the right hand side. And in cases like, let's say, you've got log, let's say, in 6x squared is r equals to log 600 base r. There is even a log
Yeah.
2 plus this one. This one, so you can't cancel because it's not only the left hand side and one log at the right
Yeah.
hand side. It comes with something. So if you cancel out this one and this one, it's going to be wrong. Are we here?
Yeah.
So with this one, you either have to change the log, the two into a log, then you simplify before you cancel out. So this is the main reason why I don't like this method. That's because if you don't take care, you can do the wrong thing easily. Now with this one, once you are very comfortable moving from
Okay.
logarithm to exponential and exponential to logarithm, it shouldn't be much of a challenge. It's longer though, but yeah, it still gets you. Are we here?
Yes, please.
Okay, so with this one, we can't do it now because we've not done series, we've not done the binomial expansion. It has got something to do, something for the Pascal triangle. I'll be teaching you this before you come to school, because it's part of the topics we'll be doing next time, but not in today's class. Okay?
So please, what? The Pascal triangle.
You don't know this one, I know, you don't know this one. Or
No.
something called computation. It's a topic we'll be doing next term. So I'll teach you this.
Uh,
That's the next one. So we'll hold on to this question because you'll not be able to solve it. But if you want to still try your hands on it, you can do the expansion this way: 2x all squared times 2 minus x all squared times 2 minus x, where you can quickly expand this one to be 4 minus 4x plus x squared, then 4 minus 4x plus x squared, then negative 2 minus x. Then you take this one, expand, you multiply it by this one. It's going to be a long process. There's a shorter way to do it. So we'll link that one later. And there's also a follow-up question because of the I'm not really going to.
yes, yeah.
Or you can, yeah, it's going to be very tough because of this one. Yeah. So let's
Oh,
skip this question entirely. When we do the series, we'll come back to it. Okay.
sure.
Okay, great. Okay, so this also under log equation. Did I teach you how to use the calculator equations?
Yes, but then it's sometimes confusing. It always gives me matter. I don't know why.
So I was expecting you to say that it gives you cancel because at times Question can be challenging to the extent that the calculator finds it a little bit challenging, like difficult to take out. Math error is a little bit out of the picture. Maybe
I feel it's because I don't input the things well, but I don't know.
math
You
error
have to.
likely that I didn't put it well. Okay, so let's do this one. Remember the advice I gave you in solving. The first thing you need to do is to make sure the log stands alone. There is no number in front of the log, right?
Yeah,
Okay, so
yeah,
it can be rewritten as log x squared minus log x plus 10 over 2 equals 1. So there's subtraction. So I can say that is the same as writing log x squared divided by x plus 10 over 2. Are we good?
yes, please.
Are you sure?
Yeah,
Okay. So we can now do the conversion from indices, so logarithm to exponential. So I can say that x squared or 10 raised to the power 1 is equal to x squared divided by x plus 10 over 2. So 10 raised to the power 1 is 10 is equal to x squared. We switch and we flip. Are we good?
yeah,
Okay, so this 10 is equal to 2x squared over x plus 10. So we can now cross multiply because x plus 10 equals to 2x squared.
yeah.
So how many marks for this
Ooh,
is 5? Okay,
I mean,
it's 5 marks. So two.
so you're breaking, oh, like,
Okay, so I was asking how many marks
uh,
n is for, but I realized it's 5.
uh,
It's a lot of marks.
yeah.
That's fine.
It become a quadratic equation, car.
Yeah, yeah, yeah. So I think I can divide both sides by 2 to make it easier. There's no need because it's paper 2. You can use a calculator.
Mm.
So x squared minus 5x minus 6. Am I correct?
Yes.
So use the calculator to solve this quickly.
It's a good, good lad. Good lad.
So
So you get 10 in minus 5.
okay, so 10 and negative 5. So
Yeah.
x equal to 10 and x equal to negative 5. So let's see if okay, so, negative 5 won't hold because of this side. Because log of negative 5 will be
Yeah.
is that okay.
Yes.
Okay, so x is equal to 10. Okay, so let's see if we can use a calculator for this one. Maybe we would get cancelled. I have a sense that we can get cancelled. So this is what we're going to do. We write the question on the calculator. So 2 log x is base 10. So where's the log to the base 10? I don't want to keep writing base 10, but you let me just write the base 10. If you write the first part, wait for me. It's like, wait for me. Are you there?
Yeah.
When you get to that
So
side,
you said,
when you get to the side, wait for me. Don't press the
okay,
equal to. Let me know when
sure.
you're there. You write the question up to that point. Are we writing the question up to that point?
So I'm almost there. Yes, sir.
Okay, to get the equal to, you press alpha and a calc key. So alpha and this one. Alpha and this. That will give you the equal.
Yeah.
Is that okay?
Yeah.
Oh, shoot. Okay. Okay, so equal to 1. When you get to this stage, you now type shift and calc. Are you there? Then you press equal
Yeah.
to. So shift and
Let's
calc
say
is equal to. So the answer is 10.
7.
If you get L minus R equals to 0, it means the answer is correct.
Yeah.
How we did?
Yes, sir.
So you can quickly use this one to check your answer before you go. So now that we know that the answer is 10, we know that we are getting all the 5 marks over here.
Oh.
Okay?
Yes, please.
Okay, so there's another one. We can either move everything to one side of the equation. Yeah, I prefer that we move everything to one side of the
So
equation.
can I try my hands on it?
Yeah, try on this. You say that right?
Say, say.
Now your computer is it a touchscreen computer?
Yeah.
Do you have a stylus?
Say, mommy. I've not yet told mommy.
Okay. So you can get your stylus then you annotate on my screen so that everyone sees what you are doing.
All right.
You can't. So I think when I'm teaching students from other schools, I'll tell them that it's a requirement to get a stylus as well, so that it becomes
Oh.
interactive class.
Say x is equal to eh, x is equal to 12.
Okay. Let's equal to 12. Let's first use the calculator and put
Yeah.
then
Sure.
put note that if L minus R is not equal to 0, it's likely your answer the calculator gives you is wrong. So 10x plus 5 is equal to 2 plus log the base 5 of x minus 7. The shift from yeah, x equal to 12. Nice, right? But let's solve this quickly for those that won't be able to get it. So we got 10x plus 5 base 5 minus log x minus 7 base 5 is equal to 2. Then this gives you log 10x plus 5 over x minus 7 base 5 is equal to 2. Then you can see that 10x plus 5 over x minus 7 equals to 5 raised to the power 2 by using the, you know what I mean, right?
Yeah.
Okay, so this will give you 10x plus 5 is equals to 25 multiplying x minus 7. Then 10x plus 5 equal to 25x minus 25 times 7. We are negative 175. Negative 175. So where should I move it? Okay, so there's negative positive 180. Positive 180.
Mm-hmm.
To
Equal to
x.
15.
Wait, is it 15?
Yeah.
Oh my God.
It's 25 minus 10.
Oh, I wonder how I got that one to be 30. So 15. So 180 divided by 15, and this will be what to be equal to 12. We already knew that because of that table like that.
Yeah.
Possible. Okay, let's write it down. Yeah, we have to solve this exponential equation. So ideally, we know that we'd have to change this one into um,
Logarithm.
logarithm. So how would you change this one to logarithm?
Log 10 base 3
Log 10 base 3,
equal to x over 2 minus 1.
yeah, because from the property we got a raised to the power x equals to b. So
Yeah.
the base is a, and log is used to find the exponent. So the answer is going to be the exponent, and this would be b. So that's what we did. Or
Yeah.
you can type log 10 base 3 on the calculator. But it's best to, as a math student, I should say this, it's best to always do your answer in the exact form. The reason why this is so, if you are going to be using math in future, like your field of work, if you are going into engineering and anything that apply math, let's assume that you are working for, let's say, Russia, where you are in charge of their nuclear weapons and other things. You are doing a calculation and you make an approximation. Trust me, the approximation won't kill your target. So let's say that your target is like, let's say, 20 meters away, but you do the calculation and you got 19.95. You approximate it to 19.95. Maybe the rockets will land in front of your target and it's not going to really do much harm. So what I'm trying to say is that once you approximate, you are turning part of the answer out. That's my suggestion not to approximate. But for
Yeah.
tax purposes, you can approximate, no problem. But as a serious mathematician, you don't approximate. So let's move to the other side to get you the 10 base 3 plus 1 equals to x over 2. How we go?
Yeah.
Okay, so from here, we can write the 1 as log 10 base 10. So log 1 base 3 plus log 10 10. Sorry, log 3 base 3. My bad. Log 10 base 10 is still 1, but because
Yeah.
the base is 10,
I using here base 3.
yeah, so that's about 2. So adding after we have to multiply. So there's basically log 30 base 3 equal to x over 2. Agree?
Yeah.
Okay. So all this is not so important. If you had used a calculator from this side, you can just multiply by 2 and you are good to go. So the next one is everything by 2. So 2 log 30 base 3 equal to x. Then I say that x is equal to log 30 squared base 3. And log 30 squared base 3. 30 squared is 900, right?
Mm, yeah.
Okay. Type log 900 base 3. Let's see. Okay, so there's approximation. So there's a better answer.
Yes. Ah, okay.
Yeah. So there's a better answer. So there's an exact answer. But like I said, we could have gone through less stress by just typing this on the calculator. So if I type log 10 base 3 in the calculator, then I subtract 1 to this one, then I multiply it by 2.
But say, I feel because of the marks,
Yeah,
like you need to.
you need to solve. No,
Yeah.
you usually get all the marks. You get 1 mark for this one, 1 mark for this one, and 1 mark for the answer.
Uh,
I guess you would have gotten 1 mark over here. 1 mark to change from the exponential to logarithm and 1 mark for the answer. So all this wouldn't be so important. But as a serious mathematician, this is the best answer for you. Okay, let's continue. Now, exponential equation involving the e function.
say,
Yeah.
say, please, I'm coming, I'm coming.
Okay. Are you like copying or you've gone somewhere?
So I'm talking to someone. Fifi. Yeah. Let's say please you can continue.
Okay. So dealing with percents of this nature, the first advice I would give you would be isolate the exponential functions. So let them stand alone,
Okay.
everything at one side, and you make sure the exponential functions stand alone. Okay,
Yeah.
that's the first thing. So I can do that by first dividing everything by um, let me divide everything by e raised to the power 2y plus then e raised to the power 2y plus 2. This will then cancel out this one, leaving you with 2 multiplying e raised to the power, because they are dividing, you can now
Yeah.
take the exponents. Make sure you put approximately on it same. So 3y plus 2.
So can you go over that one again?
So
I might forget car. Yes.
I'm trying to activate the exponential function over here by
Yeah.
dividing the the item over here. You raise the power to e, divide both sides by that. Is that okay?
Yeah.
Now taking this part of the question and applying indices, because the bases are the same and they are dividing, we subtract the exponents. So this
Okay.
exponent of the numerator and this is the exponent of the denominator. Saying that you have to be very careful not to forget the brackets, because if you forget the brackets, the negative will only affect the 3 and not affect the 2.
Yes, sir.
Okay. So we can simplify this one. So there's 2 e raised to the power negative 1 minus 2y minus 3y minus 2 is equal to 3. Then this gives you 2 e raised to the power negative
Minus one.
5y equals to 3. Is that okay?
Yeah. Yeah.
So divide both sides by 2 to completely isolate the exponential function. Is this okay?
Yeah.
Okay, now we can change this to logarithm. So this is going to be log 3 over 2 base e equal to negative 1. I didn't use the link because you said we have an issue with it. We good?
Yeah.
Okay, so log to the base e is the same as writing link. So I can now write this one as link 3 over 2 equal to negative 1 minus 5. Right? Is that okay?
Okay. Yeah.
Okay, so at this point, someone would have said that take lane on both sides so that the lane will get rid of this one. Then I didn't do it that way. I did it the way you are comfortable with. I know you can change from exponential to logarithm and logarithm to exponential. So there's exponential to logarithm. The base is e. That's why it's e over here. And log
Yeah.
substitute the exponent. So that's why the exponent is here. And the number goes with the argument. Now we can rewrite this one as 2 over 2 since the base of the log is e. And write it as the natural log of that. Natural log of 3 over 2 is equal to 1 minus 5y. So let's move the 5y to the other side and move the limit. So 5y is equal to negative 1 minus 3 over 2. So y is equal to negative 1 minus 3 over 2 divided by 5. Okay?
Yeah.
So you can type this
So
in.
say you can leave your answer in this way.
So this is the exact form of the answer. Type this one
Oh.
and get an answer.
Yes, sir.
Okay. So let's see if the calculator can actually solve this. I doubt this. Let's type this on the calculator. Let's see what we get. So y is equal to negative 1 minus 3 over 2 over 5.
Say negative 0.28 something.
This is 0.281. That is if I didn't do anything wrong. Okay, so let's see. Let's type on the calculator. So 2e exponent. The e can be shift and the length function, or alpha
Yeah.
and the 10 raised to the power 10 times 10 raised to the power x. Any of them will work. So 1 minus 2y, but I'm not going to write 2y because the calculator solves for x. So I'm going to write 2x instead. Okay.
Yes, please.
So it's equal to 3e raised to the power 3x plus 2. So shift and solve, then equal to, okay, we are correct. Negative 0.2. With this one, I
Yeah.
want to ask the answer because so this is close to zero because negative 0.9. So there's 0.00000 something here. So 2 points. No, negative
I
0.
said, isn't L minus R zero supposed to be zero?
Yeah, one minus. That's what I'm saying, that this number is close to zero because of there is a power negative 9.
Uh,
There is a power negative 9, which means that I have to go back like 9 times. So it's going to be 0.1234567.
oh, okay.
0.0000000. It wasn't exactly zero though. So, but please make sure make sure that this is very close to zero or zero. If it's not, then please don't try the answer like that. Okay. It's using something called the Newton-Raphson's method approximation to do the calculation. So, but you will learn about that at the university. Okay, so let's see if we can solve this by ourselves. Question number 6a.
Okay. Say
Yeah.
x is equal to ln 3 plus 3 over 5.
Okay, so three plus three over five. Get the
Yeah.
approximated value.
Okay, I'm coming.
And then you use a calculator to check the answer.
Say 0.82. That's approximated.
0.82. Okay, so this
Yeah.
one, divide this one by e raised to the power 4 minus 3x. Then divide this one by e raised to the power 4 minus 3x. So this cancels out this one. This gives you e raised to the power 2x plus 1 minus 4 minus 3x is equal to 3. Then e raised to the power 2x plus 1 minus 4 plus 3x equal to 3. Then e raised to the power, I think 5x minus 3. Am I correct? Am I correct with that one?
Yeah.
Okay, so we can change this one into logarithms. So we can say that log 3 is e is equal to
5x
X minus
minus 3.
3. So basically, this lane 3 equals to 5x minus 3. So lane 3 plus 3 equals to 5x. Then they divide the side by 5. 5. Mm, X equals to lane 3 plus 3 over 5. This is what you got.
Yeah, that's what I got.
So, assuming the answer is in terms of E, sorry, they can tell you to prove. I want to go further with the exact form. So, lane 3,
Okay.
3 can be written as 3 lane E. After all, lane E is 1. Is that okay?
Yeah.
Or divided by 5. So, this is the same as I think X equals lane 3 plus E lane E raised to the power 3 divided by 5. Then X is equal to lane 3 raised to the power 3. Because it's adding, we have to multiply over.
Yeah.
So, this also an exact form. But you won't really be stressed like that for O levels or IG. Yeah, you won't be stressed like that.
Oh.
Except or maybe they'll tell you to find the exact form. So yeah, let's solve this one. And if you
All
get
right.
up to confirm your answer,
Say right.
you have to
Let me try. Let me try it. Okay. So yes, I got the same thing.
okay, good.
But I don't know. My calculator took a while to respond to that.
Yeah, yeah, yeah. At times it's that way.
Okay.
Okay, so let's solve the logarithm one.
So should I solve?
Yes, yes. This quite easy
Yeah, they have the same base.
already. So
So I'm getting I.
Then there is something wrong somewhere.
Yeah.
Work on it together.
Yeah. Because I don't know where the mistake is coming from.
Okay, no problem. So the first thing we need to do is to notice that the two logarithms are summing up. So we have to multiply the arguments.
Yeah.
So log y minus 6, y plus 15 equal to 2. So we can change this one into exponential. So 10 raised to the power 2 equal to y minus 6, y plus 15. Okay?
Yes, please.
Okay, so we can either expand using for. I don't know if you know about for. First inner, outer, last.
Huh?
First outer, inner, last. There is a way to expand this one. It's faster, but anyway, let's do this. So y times y is y squared.
Yeah.
Do the last ones. So first times, so y times 15 is 15y. This times this is negative 6y. And 15 times 6 is
90. Negative 90.
negative 90.
Yeah.
Okay. So the 90 goes to the other side, or like the 100 goes to the other side. So y squared minus 9y. My math is correct.
Say plus 9y.
Okay. Plus 9y. Then this would be minus 190. Did you get this?
Yeah, you get error. AI.
Are you sure?
Yes, please.
I got some. Then negative 19.
Hey.
Check the inputs well.
Yeah, then maybe I didn't think so. But then I go up to that side today. Yeah.
Okay, we'll finish up. We are not done.
I used plus 90, 190. That's why.
Okay. So did you get a 10 and negative 19?
Yeah.
Okay, so we can now say that y is equal to 10. We ignore
Yes. Because
this
the negative 19 will,
value.
can be solved.
No solution. No real solution. Okay, so 5 marks over there. Write this one as a single variable. So the log itself is not that challenging, right?
Yeah, yeah.
We talked about it. We have no questions to solve.
So log 10 square x squared over y squared.
Log 10 x squared y
Sorry,
squared.
over y.
Y squared over y. I doubt it.
No, I said log 10 squared x squared over y. That's all.
Okay, I doubt it. I doubt it. This can be written as log x cubed. I was expecting x cubed somewhere.
Hey,
Plus, there's the same as I can log 10 squared all over 100
say
minus
10 square x cubed. Sorry.
y. So this would be log 10 squared, so 100x cubed over y. Okay. Uh,
Yeah. M square x cube. Alright.
okay. Solve this one. So this one is also easy. I think we should just ignore this one. Okay. This is also very easy. So log
Yeah.
x plus 1 and solve more challenging questions equals to 2.
2 raised to the power
2 is
3
power
equal
3.
to x plus 1 y. Because multiply 8x equal to x plus 1. 1 over 7. Yeah.
You get?
Yeah.
Okay. Okay. Let's see if we can do this one.
See, I'm confused. Wait.
Think about it well.
Yeah, I'm checking. Yeah.
Should I come in?
Yeah. Yeah.
Nah, you're too lazy.
Ah, no, I say like, wait, I'm coming. Hey, it's also just on one mark. Oh. These questions piss me off. Oh.
The question started with a preamble in
Yeah,
exponential form, and we're told to
yes.
answer in logarithmic form. So the first thing that should come in your mind is to change the exponential form to logarithmic form.
Yeah.
That's turning a raised to the power 7 equals to b into logarithm. What would it be?
Log B is equal to 7.
So the answer is equals to 7.
Yeah.
Are we good?
Yeah, 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 yeah,
Then
yeah,
log ab is the same as writing 1 over swap of bases. Log
yeah.
b base a. Is that
It's
okay?
1 over 7.
So that is equal to 1 over 7. So how difficult is it?
Yeah.
Continue solving.
Say, y is equal to 81 raised to the power negative 1 over 4.
If you type on the calculator, what do you get?
I'm on it. 1 over 3.
Okay, attempts, let's see.
Okay. Looks interesting.
Any idea that's how to do this?
Yeah, I say I'm almost done.
Okay.
So square root of 3. That's the answer, I think.
Final answer.
Yeah. I
Okay.
got two answers though.
Okay. How did you do it? I don't know. We can check using the calculator, but let's solve it first. How did you do
So I changed all of them to base 2.
it? Okay.
And I took it one by one. So I got 2 raised to the power of 5, open bracket, x squared minus 1. No, 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 no.
Like the same.
Okay, yeah, 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 yeah. And 2 raised to the power 2 x squared. Yeah, x squared. So from here, like since the bases are the same, I subtracted since it's erases. So 5x minus 2x squared.
Oh, but this one is even indices. Let me get
Yeah,
the series of 4.
4
So this will be 3x squared minus 5 equal to
equal to 4.
then
X squared minus 9.
3x squared equals to 9. So 3x squared equals to 9. Then x squared equals to 3. Then x is equal to 5 minus 5 plus 3.
Yeah, plus one. Yeah, that's why I said I got two answers. Yeah.
Okay.
And it can't be minus. So then that's why I said it's just go to.
It can be minus. In this question, it can be minus.
It can't be minus.
Yeah.
I only get a valid answer.
Let's try and see.
Okay.
So, so 32 raised to the power x squared minus 1 over 4 raised to the power x squared. So calc x equal to square root of 3. That's a calc and approximately 2 square root of 3. Was it 16? So this one is not
Okay.
both answers are accepted. X equal to positive and negative square root of 3. Okay?
Yes, yes, please.
Okay. Let's open indices. Let's ignore the indices
Okay.
because everything can be given in terms of 3.
Indices is easier,
Yeah,
I
and
think. Yeah. So what's this? Is
you
logarithms.
can give me your answer in terms of solve for B. You have to make B the subject. So it's the same thing. Move on to the other side. Yeah, the bits are not the same, so be careful. Attempt this one for 5 marks.
Okay, let me try it. So I'm getting long decimals,
That's now.
and I got two equations. Is it?
Let's see. A is greater than zero, B is greater than zero. And we have to write this in terms of find B in terms of A. So um, log square of B minus log square of A base B equals 1 and 2. To do at least this and this form.
So I changed log e square root of b to base b.
Change base B.
Yeah.
That would be a little bit
It
complicated.
will be log b half b raised to the power 1 over 2 over a.
So we want it that way instead. We change this one to base B. So
Yeah.
B raised to power 1 over 2 base B over 3 base B. Is that what you mean?
Yeah.
Minus A base B equals 1 over 2. Yesterday I was saying that we are dealing with something that
Yeah.
throughout we can clean up a little bit. So let's clean up a little bit so that we don't get ourselves confused. So I'll let this one be M. Log B raised to power 1 over 2 base B is going to be 1 over 2. So 1
Yeah.
over 2 over M minus M all to 1 over 2. Do you agree?
Yes, please.
So I can multiply everything by M. So this gives you 1 over 2 minus M squared equal to 1 over 2 M. Is that okay?
Yes, please.
So multiply everything by 2 again. So 1 minus 2M squared. Um, equal to,
So I see where my mistake is now.
okay, so 2M squared minus plus M minus 1 over 0. I took the 2 and put it on the side. As you get it. So we solve for the we get
So get 1 over 2 and minus 1.
so 1 over 2 and minus 1. So M equal to 1 over 2. And then equals negative. So from the beginning, it was log A base B. So log
Hmm.
B So you can say that A is equal to 1 over 2. Sorry, B raised to the power 1 over 2. Okay?
Yeah.
So B raised to the power 1 over 2. We are finding solving for B in terms of A. So I have to square both sides. So you can say that B is equal to A squared. Is that okay?
Yeah.
Then also we got log A base B equals -1. So A equal to B raised to the power -1. So this is simply writing 1 over B. B is equal to 1 over A.
Yeah.
So there are two possibilities. So A equals to um okay. Okay. Can I continue? Can I continue?
Yes, please.
So where did you go wrong?
Then they when they multiply 1/2. So normally, like, so Costa was like, we should put a 1/2 in front of the log when you are changing the base.
Okay.
Yeah.
But that is also correct. But
And when I did that,
you
I
don't
got
look it up. So let's do it the way your teacher told you to do it. So there's going to be 1 over 2 log B B base A. Is that okay?
yeah.
Then this will be swap of bases. So this will be 1 over log A base B. The same thing.
So when you multiply, I
When
cross multiply. So I got 2/log A over B.
you do over this one,
No, I got 2/log A over B.
how
Oh, you're supposed to only multiply the half by 1.
so
Oh,
you're multiplying fractions. You multiply the numerators and multiply the denominators.
yeah. Okay. Then say, I get it, I get it, I get it.
Okay.
I made a mistake. That's it.
This one we solve similar one. I think we solved similar one. This one
You
go
solved this one.
so let's go. What of this one? This one looks complicated. Let's solve it together. There are a lot of ways to go about it. The first would be dividing them by saying that the exponents and the bases are the same, so we subtract. That's the first mistake. So
So you say,
I said the first mistake you are likely to do will be doing it this way, where you are subtracting the exponent. This is not possible because
oh,
of addition in between them. So that's important. What I will do for this question will be cross multiplying. So I've got 2 x raised to the power 1.5 plus 6 x raised to the power -0.5 equal to x multiplied 0.5x. Sorry, x raised to the power 1.5 plus 5 x raised to the power -0.5. So this gives you 2 x raised to the power 1.5 plus 6 x raised to the power -0.5 equal to x times x will give you x raised to the power 1 plus 0.5. The bases are the same. We add the exponent. Is that okay? If that's okay.
yes, please.
So this will be
Yeah.
1.5 plus 5 x raised to the power 1 minus 0.5 will be 0. How is it?
Yes, please.
Okay. So this can then be written as 2 x raised to the power 1.5 plus 6 over x raised to the power 0.5. You agree?
Yeah.
It's equal to x raised to the power 1.5. Then plus 5x 0.5. Is this okay?
Mm-hmm.
Is this okay?
Yes, please.
Then I multiply everything by x raised to the power 0.5 to create the denominator. So that's x raised to the power 0.5 minus x raised to the power 0.5, x raised to the power 0.5, x raised to the power 0.5. So if you multiply this one, the bases are the same. So 2x raised to the power 0.5 plus 1.5 is 2 plus this will cancel out the term 6 is equal to x raised to the power 1.5 plus 0.5 is equal to 3 plus 5. 0.5 plus 0.5 is 1. Okay. Is that okay?
Yes, please.
Okay. So moving the x squared to the other side, we get 2x squared minus x squared minus 5x plus 30. Then so
Wow.
yeah. So we solve the quadratic equation. I think we
So
actually
3 and 2.
yeah, x equals to 3. Contact this thing. Yeah, it looks complicated, but you have to take your time. This is purely in this. Yeah, it's purely in this. Is that
Yeah.
is this okay?
So you're breaking.
The network is bad. Is this okay?
Yeah, yeah.
Okay. Question number 12. Question number this. Let me see how many questions we are left with. There is a lot. We can't finish after this. Try to do it.
It's evening time.
Yeah.
I
So
reading style. That's why.
yeah, we started like 15. Okay, so this one can be quickly solved. This will be log 6 base 2 equal to 3x 1. And I think that was it, right?
Yeah.
We change from exponential to logarithm. This one to we have to do swap of bases. So let's do this one. This will be the last question.
Okay.
Log y plus 14 base 3 is equal to 1 plus 2 divided by, let me write it this way instead. Log 3, you good?
Yeah.
So log y plus 14 base 3 is equal to 1 plus 2 divided by, swap of bases, 1 over log.
T Y A
So
Y T.
that's it.
Yeah.
Okay, so this would be log y plus 14 base 3 is equal to 1 plus 2 which is okay.
Yes, please.
Okay, so this gives you log y plus 13 base 3 is equal to 1 plus 2 log y base 3. The advice I gave you from the beginning, make sure there is no number in front of the logarithm. So this can be written as log y plus 14 is equal to 1 plus log y squared base 3. Is it okay? Is it okay?
Is it?
Is it okay?
Yes, please.
So grouping all the logs at one side. So log y plus 14 base 3 minus log y squared equal to 1. Then we are subtracting. So this will be log y plus 14 over y squared base 3 equal to 1. And we can change from logarithm to exponential, then we solve from there. So this will be 3 raised to the power 1 equal to this. So 3 raised to the power 1 is 3. This equal to y plus 14 over y squared. First multiply the 3y squared equal to y plus 14. So 3y squared minus y minus 4. Then we solve the quadratic equation. So let's solve the quadratic equation. If over 2, can you get calculator?
7/3 and -2.
So y equals 7 over 3 and y equals -2. So let's see which one is going to take. Um, the base can't be negative. The base can't be negative. So can you see my screen?
Yeah.
Okay, so we can say that y is equal to 7 over 3. That's the answer to the question. So that'll be it for today. When are we meeting again? I think next week, right?
Yeah.
Yeah, yeah. So next week we'll finish up then. We'll do the word problems, the application, like this one. Then
Okay.
we'll look at the graphs. When we finish everything on time, we'll do the topic we start with during this step. Okay, so take care of yourself. We'll meet next week. And I'll post
Yes, you too.
it. Okay, bye bye. Don't forget to
Bye.
comment as well.
Sure.
Yeah.